Greetings everyone. Greetings everyone. I am Udaysharma from the EEE Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic demonstrate distribution of demonstrating sorting flash sorts. Distribution sort is a popular method for sorting in distributed memory environments. We will implement distribution using sort buckets. The idea is first participation to the input set into several buckets and then independently sort the buckets and write the sorted buckets to an output array. In this problem, we assume that the data is already available at reach. After each rank has finished sorting list buckets, we leave the sort data distributed at each rank. Example, assume that the data cannot be stored in main memory on one node. Input rank 2. Here, this is sent to this side, this is sent to this side. Sorted local data, and here we get the sorted data 1, 2, 5, 7, 8, 9, 8, 8, 9, 11, 11, 12, 13, 17. This is a sorted list. And this is the input. The algorithm performs best when the number of elements in the bucket list are evenly distributed. The programming activity below, you will use uniformly distributed data. This shows a cartoon example of a histogram of 5 buckets with equal width. Each bucket consists of same number of elements. Your buckets will contain nearly the same number of elements. Bucket 1, bucket 2, bucket 3, bucket 4, and bucket 5. Cartoon example of histogram using uniformly distributed data. Here we can see the different sorting techniques like bubble sort, heap sort, merge sort, selection sort, insertion sort, and quick sort. Faster alternative is based upon the sample. Is distributed implementation of sample sort algorithm as follows. Each compute denotes sorts data with fixed number of equidistant samples. Samples are sent to the master rank, who will sort them and collect samples from the set of received elements. Final sorting of data, each memory rejoins the complete balanced state of network. This method is computationally very efficient. The number of operations is constant, independently of the input size of the network size. However, it may lead to the high heterogeneous number of elements across number of nodes. Flashsort algorithm. We can see this is an algorithm for flash. The algorithm proceeds to finding the smallest or largest depending on the sorting order. Here we can see the run times. The runtime for sorting n random strings of by 1 byte length as a function of n using a PC with one single processor and full version. The runtimes are measured disregarding the whole leaf. The measured runtimes do not rely on the straight line. N is equal to 10 power 6 strings are shown in the function of the position of flash cycle. The leader and permute are extended in turn into the sorting keys. Empty if AI has not been replaced by the same other element. Flashsort algorithm. Components in the unsorted exchange. If the leftmost unsorted component and moves sublist boundaries one to right, it has over 2 time complexity, which makes it sufficient large performs worse than the insertion sort. Thank you. This is Udaysharma signing off.